All right, let's go ahead here. Take a look at section 3.6, which is quadratic inequalities. Now, you guys have been graphing quadratics since chapter 1, since Algebra 1, in all honesty. And so you should be pretty much, hopefully at this point, caught up and familiar with how to graph these quadratics. So now, what we're going to add to this in this section is the fact that we're going to have inequalities. And inequalities will change not necessarily the shape of it, but how you draw the curve. So we have 3 steps right here. And it says graph the inequality or graph the parabola with the equation y equals ax squared plus bx plus c. So what they're saying in the beginning is, look, you don't have to worry about the inequality. Just graph it as though it's a regular equation. So, but the thing here is this. In the second sentence, it says make the parabola dashed for inequalities with the less than or greater than sign. So if I were to have a parabola and it's dashed like this, then you're going to have either the less than or greater than symbol. And it'll be a solid parabola like this if it happens to have the less than or equal to or greater than or equal to sign. And look, this guy, it looks like sort of like a mad face. But whether you have greater than or less than does not really determine the direction of the parabola. It's still your A term. Will tell me if it's going up or down. But once again, the thing here is this. If it is dotted or dashed or solid, then that's going to be based off of the inequality. The inequality will also tell us where to shade. And that's where we go to step 2. It says test the point xy inside the parabola to determine whether the point of the solution is a solution of the inequality. So if I were to pick a point on the inside of the parabola, and it happens to be a true statement when you plug it into the equation, then you will shade on the inside. If it happens to be false, the equation, then you will shade on the outside. So there's step 3 is all about shading and making sure you plug in the number or you plug in a point and make sure to see if it's correct or not. So let's go ahead and scroll down here. And take a look at these problems. So it says to match the graphs with the inequality and explain the reasoning. Okay, there's 4 things that I look for if we're looking at like a matching question like this. But this applies to, remember, even if you're graphing it in general. Step 1, you want to look at the inequality because the inequality will tell us whether we have a dashed line or a solid parabola. So that's one of the first things. If I take a look at number 1, I could already eliminate option B and D because that's the less than or greater than symbol, or less than or equal to, greater than or equal to symbol, which does not work. Next up, look at the A term for direction. Okay, you want to figure out, is it going up or down? So if I look at number 1, it's facing upwards, so that tells me my A value should be positive. So letters B and D, we could already eliminate. We could already eliminate B and D because the less than, equal to, greater than, equal to symbol represents a solid parabola. Another trick, step 3, look at the C term for the y-intercept. The y-intercept right here, remember, is your C term. So if I look at number 1 and I take a look right here, where is it crossing? That looks like at 0, -8. Well, all the equations seem to have -8 as the y-intercept, so we can't really use that one in this question. Number 4 is plug in the point to determine the shading. So that'll definitely take us home to figure out which is actual inequality. But if I look at number 1, all right, once again, I can determine that it's going to have to be either A or B, or A or C, because of the inequality. It's a dotted line, so it has to be A or C. So we go look further. I look at the direction, it's going up. I look at the A terms in both A and C, they're positive, both going up. All right, so it's still between the two. The last thing right here is let's figure out which would make this statement true. So I'm going to pick a point. Let's pick an easy one. That one right there. That one happens to be at 4, 0. And let's plug it into our inequality. And so we'll have 4 is less than or equal to, or sorry, less than, sorry, let's try this again, because y is 0, and that's less than 4 squared plus 2 times 4 minus 8. So it looks like right here 0 is less than, that's 16, that's 8 minus 8, that'll leave us with 16. So 0 is less than 16. That right there sounds like a true statement to me. So since that's true, what I can go ahead and say right here is that letter A is the equation that goes with number 1. Now, with number 2, it should be letter C. Well, let's prove that. Let's pick a point right here inside of number 2 and 0, 0. I always want to try to pick an easy one. And so if I go ahead and plug things in, 0 is greater than 0 squared plus 2 times 0 minus 8. And so this right here will simplify down to 0 is greater than negative 8. That right there sounds like a true statement. That makes number 2 letter C. Let's go ahead and take a look at 3 and 4. So once again, those have solid lines right there, or solid parabolas. And they're solid because it has the greater than or equal to, less than or equal to symbol. Now for number 3 right here, let's pick a point, because I already know that the inequalities look good. The direction, there's that good old train. When we look at the A term, they're both going downward, so they're both negative. That looks true for both B and D. The y-intercepts are the same, so I have to pick a point. So let's try number 3 with 0, 0. Okay, any point works, right, as long as it's shaded. So let's see if this is correct right here on letter B. If I go ahead and plug things in, 0 is less than or equal to negative 0 squared plus 2 times 0 minus 8. So is 0 less than or equal to negative 8? That sounds like a true statement. That means right here, well, let's see, let's double check. Make sure I got everything together. Is less than or equal to negative 0. Now this right here, that's a false statement. 0 is not less than or equal to negative 8. So number 3 cannot be letter B. Number 3 right here will happen to be letter D. Let's just double check right here. We'll plug in 0 greater than or equal to all this stuff. And 0 is greater than or equal to negative 8. This right here is true. And so that means number 3 is letter D. And do the process of elimination, but we also proved it right here. Number 4 is letter B. Because remember, if I pick 0, 0, it should not be shaded, and that makes it false. And that's why letter B happens to be number 4. Let's go ahead and move on here. Another thing that you're going to be doing is going to go ahead and all right, let's take a look at number 5. How do we graph an inequality, just in case we go through this again? Remember, if it's not in vertex form, then you're going to have to make sure you know how to graph by using points. Okay. On a test, you're not going to be able to use Desmos. You're supposed to be able to graph these by hand. All right. Now, if I take a look right here, if we remember from chapter 1, there's no horizontal shifting. It's just vertical right here at positive 2. And remember, this positive 2 is your y-intercept or your c term, and that happens to be right there. If it's not shifting left or right, then that tells me that in this problem, your vertex happens to be at 0, 2. So then you go ahead and plug in numbers 1, 2, -1, -2. So we can go ahead and plug things in, solve it out. You plug in 1, you get yourself 3. -1, you'll get yourself 3 as well. Remember, these are supposed to be the same because it happens to be a reflection, right? Symmetric, and then they reflect across the y-axis. You plug in 2, so 2 squared is 4, plus 2 is 6, and 6. So that'll be up here. We have the idea of where it's supposed to be. All right. So, graph the inequality. Well, what do? We got to find a point and make sure that it figure out where is the inequality true. So let's try right here. Let's make it easy. 0, 0, make that your friend. And so if I pick 0, 0, and the inequality is a true statement, then I will shade on the outside. If not, then I'll shade on the inside. So let's see. 0 less than 0 squared plus 2. 0 is less than 2. That does not look like a true statement. So I do not shade on the outside, where I must shade right here on the inside. Oh, sorry, 0 is less than 2. My bad. That is a true statement. We should be shading right here on the outside. Hopefully you caught that. 0 is less than 2, so there is your graph. All right, let's go ahead and move on to number 10. Now you're going to see times in where you might have to graph 2 quadratic inequalities. So let's do that right here with number 10. Okay. Let me go ahead and draw some lines here. All right, so y is less than or equal to negative x squared. All right, so 1, remember, the less than or equal to should tell me that it is going to be a solid parabola. Now, I already know what the points are, having done this enough times. Now, this is your standard parabola. It's the vertex is at 0, 0. And then we go -1, -1, -2, down here at -1, 2, 3, 4. Okay? And so that much you should hopefully have picked up at this point in time. If not, you will eventually get it because you do this so many times. But let's say for the second equation right there, we've got to figure out things with the table. I should know where the y-intercept is. It's at positive 3. Remember, the -3 tells me we have a vertical stretch and it's going downwards. So I know that it's not shifting left or right, so my vertex here is at 0, 3. So 0, 1, 2, 3, there's my vertex. It is going downwards. We gotta pick and choose our points. When you plug in 1 into the equation, we got ourselves 1 squared is 1, times 3 is -3, plus 3 is 0. So 1, 0, -1, 0. All right, let's plug in 2 right here, and looks like you'll get -8 and -8. So we got 1, 2, 3, 4, 5, 6. Let's see, 7, 8 further down. So it'll be somewhere down here. And let me go ahead, we'll draw the function, and it will look, it has something like this. The one in red happens to stretch out, so it does intersect with the one that's in blue. Okay? So the last thing right here is we have to figure out where we shade. We have to figure out, well, where is it true for both equations? Okay, not just for one, but for both. So let's start off right here. We could choose, for example, 0, 1. Okay, so if I plug in 0, 1, I want to make sure, is that true for both of these? Okay, and if they are, great. If not, then we got to keep moving on. So if I choose 0, 1, let's go ahead right here. 0 less than or equal to, we got 1 squared. Well, we got negative 1. Or sorry, let's put in the 1, and then we have the negative on the outside. Okay, so 1 squared is 1. 1 is less than or equal to negative 1. All right, that right there, is that a true statement? 0 is less than or equal to negative 1. Not true. Okay, so that's not going to work out. But if I plug this into here, into the bottom equation, it does work out, because 0 greater than, we got negative 3 times 1 squared plus 3. All right, so 1 squared is 1 times negative 3 plus 3. 0 is greater than 0. Well, that's not really true. So therefore, that doesn't work out. So we got to pick another point. Pick a point like in here. We could pick, for example, 0, negative 1 and see if that works. When you plug in 0, negative 1, you'll realize that I'll do a little fast forward, that it does not work for the top equation, or the one in red. It does happen to work for the one in blue. To save us some time right here, what I was able to find is that it's this little sliver where it overlaps right here. That's where it's true for both. Okay? And so by picking points, you'll hopefully eventually find, all right, this is a part that happens to work for both of them right here. And that is the exact spot where you want to shade, and only that spot. All right, but the only way to figure that out is by plugging in different points. All right. So it can be a little tedious and time consuming, but it's not that bad. All right, let's go ahead and move on right here and go to the last part, which is solving the inequalities. Algebraic. All right. So let's go ahead and solve this out. If I take a look at a question like this, one of the easiest things to do is, well, first, let's not worry about the inequality. Let's just try to solve things. So we can solve things using whatever method that we learned, factoring, quadratics, quadratic formula, complete the square, then you can do that. However, let's go ahead, let's set this equals 0. So I'm going to go ahead and subtract 100 to both sides. And let's go ahead and solve things out. All right, let's see. Looks like right here, this happens to be a difference of 2 squares, because I could take the square root of the a term. Square root of 16 is 4, square root of x squared is x. The square root of 100 is 10. So you got 4x plus 10, and 4x minus 10 is equal to 0. Remember, we want to take these two equations, solve them out. So 4x is equal to negative 10, x is equal to negative 10 over 4. And some of you guys, you don't show the steps. Please show them when you're doing your homework. All right, so we got 4x minus 10 this time is equal to 0. You got 4x is equal to 10. and then x is equal to 10 over 4, which is now positive 5 over 2. All right, so the last thing right here, in order to figure out the true answer of our inequality, is let's go ahead and draw ourselves a number line. We'll go ahead right here. I've got 5 halves. I've got negative 5 halves on my number line. And what I'm trying to figure out is where is it true? Okay, if I plug, now this has to be, it says it's greater than. So this is where the inequality is important. Remember, on a number line, when it's greater than or less than, we actually use an open circle. Okay, so we have an open circle here, an open circle over negative 5 halves. So what I can go ahead and try to figure out now is this. Is it true in between? If it's true, then let's plug in 0 into our equation. If I plug in 0, is that a true statement where 16x squared minus 100 is greater than 0? Okay, so let's go ahead and figure that part out right here. Or let me go ahead and change the inequality. So 0 squared is 0 times 16 is 0 minus 100. So is negative 100 greater than 0? That is not. So from 5 halves to negative 5 halves, it's not true. Let's choose a number that's greater than 5 halves. For example, well, we know 2.5 happens to be hopefully 5 halves is equal to 2.5. So let's plug in 3. If I plug in 3 into the equation, you got 3 squared is 9. All right, so we got 3 squared is 9. Multiply that by 16, that's 144. 144 is greater than 0. So what that tells me is going to go this way. All numbers greater than 5 halves are true. Now let's figure out if all numbers less than negative 5 halves are true. So you can plug in negative 3. And when you actually plug in negative 3 right here, and you plug it into the equation, you'll get the same result, and it is a true statement. Okay, so the last thing is here is this. When it goes in opposite directions, we have to go ahead and say that x is less than negative 2.5. And then the important part here is or x is greater than 2.5. And that would be your answer. We call this a disjunction. So when there's a disjunction, we use the word or. When the middle part is connected, then we use the word and. So what I'm trying to say here is this. If, okay, it's not on this question, but if these two, if it was true in between, then what we would do right here is say that x is less than 5 halves or greater than negative 5 halves. And what we could also say here is this. If x is less than 5 halves, and then we use the word and x is greater than negative 5 halves. And we would do this when we have a conjunction. We have the connection of the 2 points right there. Okay, so we would have an open circle. Don't forget, open circle if we're using greater than or less than. We have a closed circle if we had the inequality of less than or equal to or greater than or equal to. All right, so those are all big things right there for you guys to make sure you know how to do when you're solving these problems. Let's try one more. I'll make one up right here. Okay, so let's go ahead and say we have x squared minus 3x minus 4 is less than 0. So in this instance, let's go ahead and let's see if we could factor it out. And I've got, let's see, looks like I can have x minus 4 and x plus 1 is less than 0. We can go ahead and solve this out. We got x is equal to 4, x is equal to negative 1. So let's make our number line right here. And I've got negative 1 over here. I've got 4 over here. Now, based on my inequality, we have the less than symbol. So that means, once again, we have open circles. Okay? Is it always open circle? No. But in this instance, because it's less than, that's what we're going to have. So let's figure out where is the functions true. I could plug a number in between. That would be 0. So if I plug 0 into here or up here, will that be a true statement? So 0 squared. Okay, so let's go ahead. I plug in 0. 0 squared is 0. We got negative 3 minus 4. That's negative 7. Is that less than 0? That is true. So that means that in between right here, we have ourselves a conjunction. Now, I would say probably like 95% of the time, that's what's going to happen. Sometimes you will need to choose, you should choose other numbers, because it could be that this might be true going one way, and negative 1, all numbers less than 1 are also true as well. But in this instance, it happens to be works out where these two right here are both, that is the boundary of making this statement true. So right here, remember, in this instance, what I'm going to go ahead, we could write this as one inequality where x is less than 4 when x is greater than 1. Or we could use the word and when x is less than 4 and x is greater than 1, we have a true statement. So you could have your answer both ways. All right. Remember, it changes up where it's a closed circle if we do happen to have a greater than, equal to, or less than or equal to symbol. All right. So hopefully that should get you ready in completing section 3.6 on your own.